All right, let me demonstrate that. Okay. So for this example, we're going to calculate probabilities of A or B. So let's suppose we flip a coin, okay, you know, a two-sided coin, and then we roll a die. Let's find the probability of the coin landing heads up, you know, landing heads up, or rolling a 6 on the die. I mean, before we did and, right? But now we're going to consider or. So we're not going to use the formula, not yet at least. What we're going to do, though, first is let's just solve it by looking at the sample space, right? I mean, here it's not so hard to list the sample space, right? We have H1, H, remember, means the coin lands heads up. And the numbers, of course, are what we roll in the die. So we have H1, H2, H3, H4, H5. You know, in other words, we get the coin lands heads up, and we roll a 1, a 2, a 3, or a 4, and so on. And T, of course, means the coin lands tails up. So the sample space here, we're listing all the possibilities. Well, okay, so what are the outcomes where the coin lands heads up or we roll a 6? Well, I have that listed here. In other words, the event we're looking for, the coin landing heads up or rolling a 6, that's these, right? These are the coin landing heads up. Okay, what about rolling a 6? Well, we have the coin landing heads up and getting a 6. That's possible. That's already in there. But we also have this one. This is the coin landing tails up and we roll a 6. Okay, so just by using our probability definition directly, our probability would be 7 out of 12. 7 out of 12. All right, so we know that's the right answer. Let's try the formula, though. And when we do that, you'll see why we have to subtract here. Basically, again, whatever's in A and B, you end up counting that more than you should, and that's why you have to subtract. Okay. So again, let's use the formula. So we're going to let A be the event that the coin lands heads up. We're going to let B be the event that we roll a 6 on a die. Okay, so for event A, what are the outcomes? Well, again, here the coin lands heads up. So what are those outcomes? We have H1, H2, H3, up to H6. These are the only outcomes in our sample space where the coin lands heads up. So the probability of A is we can count the outcomes, 6 out of 12. I mean, that is a half as well. Okay, what about B? Well, for B, B is the event that we roll a 6. How many outcomes are there? Well, we want to roll a 6, so we don't care about the coin, so to say. So we have H6 and T6, right? H6 means the coin lands heads up. T6 is that the coin lands tails up. So in this case, the probability of B would be 2 out of 12, which is 1 over 6. But what about A and B? In other words, the coin landing heads up and rolling a 6. Well, there's one outcome for that, right? H6. So in this case, the probability of A and B would be 1 out of 12. Okay. So again, as I said here, if you were just to add up the number of outcomes in A and the number of outcomes in B, you would see that you're counting what's in the intersection, excuse me, what's in both more than once. That's why you have to subtract. If we use the formula, we have probability of A, 6/12, probability of B, 2/12, probability of A and B, minus 1/12. We subtracted, that is, and we get 7/12, which is this answer. So that's why the formula works. Well, I mean, it's not a proof, so to say, but it's just demonstrating the formula. Okay. All right. Any questions at all? All right. Well, we also could have the possibility where two events have nothing in common. You know, that can happen. In such a case, we say, well, excuse me, that's not what I meant to say. We have this definition, that's really what I meant to say. The probability, two events are said to be mutually exclusive if the probability of A and B happens to be 0. In other words, it's impossible for events A and B to occur at the same time. So that's what it means to be mutually exclusive. If the probability of both occurring of the event and the other one is 0. What's nice about that is to get the probability of OR, right? You just add up the probabilities. You don't have to worry about overcounting. That is, you don't have to subtract, right? If you go back to the formula, if A and B are mutually exclusive, this thing's going to be 0. So you just add. That's all, which is nice. That's what happens here. Okay. Again, I misspoke about having nothing in common, but I want to be more careful. So again, I apologize for that. Okay. Good. Okay, well, let's do some examples. Okay, so here, let's suppose we have a standard deck of cards just like before. And again, we're drawing a card at random. So we're drawing one card at random from the deck. You know, the deck is well shuffled, no tricks, nothing like that, okay? So let's let A be the event that the card we draw is an ace. Let B be the event that the card we draw is from the suit of clubs. What would the probability of A or B? We're going to find the probability of OR. So we're finding the probability of A or B, right? Well, by the formula, we have to get the probability of A, the probability of B, and the probability of their intersection, of A and B. Okay, so for A, what's the probability that the card is an ace? Well, there's 4 aces in the deck, right? And there's 52 cards in the deck, so we have 4 out of 52. And for B, how many cards are there in the suit of clubs? 13 out of 52. 13 out of 52. Now, A and B. How could A and B occur? Well, that can occur. What's the probability? Well, there's only one outcome in A and B, right? Drawing an ace that's in the suit of clubs. That's how A and B would have to occur. You would need the outcome to be, you would need both events to occur. That is, you would need an ace in the suit of, from the suit of clubs. And there is only one. So the probability of A and B would be 1 out of 52. So the probability of OR, A or B, probability of A, probability of B, you add them, minus the probability of both, A and B. Using this, we have 4 out of 52 plus 13 out of 52 minus 1 out of 52, which turns out to be 16 out of 52. Remember, when you add fractions, right, If the denominators are the same, you just add or subtract the numerators. That's all it is. Any questions on this? Okay, so this one I want everyone to try. It'll take about 3 minutes, so let me stop the recording. Take about 3 minutes on this one.